Bismillahirrahmanirrahim. Dear students, our topic from all these days was this quadratic equation, how to solve a quadratic equation. Quadratic equation, you know the general form of quadratic equation is ax square plus bx plus c is equivalent to 0. This is the general form of quadratic equation, and we find the roots or zeros of this quadratic equation by the method known as factorization method. Second method, completing square method. These two methods we have discussed these two methods in detail. Now the third method is quadratic formula. Third method is quadratic formula method. By making use of this quadratic formula, we can also find the roots of a quadratic equation. So these are the three methods. First two methods we have already discussed them in detail. Now today we shall find what is this quadratic formula. First of all, let us see what is the general form of quadratic equation. Let us derive the quadratic formula. Here what we do in the completing square method, all those steps which we follow in this completing square method, we shall follow the same in this equation to develop the quadratic formula. Here we go. First of all, ax square plus bx is equivalent to minus c. We have just shifted this constant term towards right hand side. Then dividing each term by the quotient of x square, that is a. Here we see that quotient of x square is a, so we are dividing here ax square divided by a is equal to plus bx divided by a is equal to minus c divided by a. A and a will get cancelled. We are left with x square plus b by ax is equal to minus c by a. So these two steps we have done it in the completing square method. And the third and all important step, you know what is that? We are adding both sides 1 by 2 into quotient of x. What is that? It is b by a whole square. This is equal to b by 2a whole square. b1s are b, 2 into a is 2a, so b by 2a whole square. This is a term that you are going to add it to the left hand side as well as to the right hand side, so as to complete the square. So you already know it, you are familiar with it. All these steps we have done so far. First of all, we are shifting this constant term towards right hand side, and then dividing each term by the quotient of x square, that here we know it is a here, so we are dividing x square divided by a, bx divided by a, and minus c divided by a. Then the third step, very important step, is that we are adding 1 by 2, 1 by 2 is 1 by 2 into quotient of x. What is here? It is b by a whole square to both sides, that is b by 2a whole square to both sides. So as to complete the square, x square plus b by a x plus b by 2a whole square. This term we are adding this to the left hand side, same terms is to be added towards that to the right hand side also, plus b by 2a whole square. So we are adding this b by 2a to both sides. Here the square is completed. This will become a plus b whole square, and for a here we have here x plus b by 2a whole square is equivalent. This is minus c by a plus, what is this? This is b square by 4a square. B square means b square, and 2a whole square means 2 2s are 4, and a square is a square. So proceeding further, x plus b by 2a is equal to x plus b by 2a whole square is equal to, by cross multiplying, this is minus 4a square c plus ab square 4a cube. So proceeding further, this is x plus b by 2a whole square is equivalent. Let's write this ab square minus 4a square c divided by 4a cube. Proceeding further, this is x plus b by 2a whole square is equivalent. Taking a common, this is b square minus 4ac. We are taking a common from the numerator and also from the denominator. We are left with 4a square. A and a will get cancelled. We are left with x plus b by 2a whole square is equal to b square minus 4ac divided by 4a square. So x plus b by 2a whole is equivalent. The square will go and we will have a root for this b square minus 4ac divided by 4a square. Now see the denominator, it is a perfect square. So this is x divided by b by 2a. X plus b by 2a is equal to under root of b square minus 4ac divided by under root of, this is under root, this is 2a whole square. Square and root will cancel for this denominator, not for the numerator. So we are left with x plus b by 2a is equivalent, this is plus minus here, this under root of b square minus 4ac divided by 2a. Now we are supposed to find the value of x, so this term is to be shifted towards the left hand side. So here we go. Let's write here. So this is x is equivalent to minus b by 2a. When you are shifting this b by 2a towards the right hand side, signs will change. Plus minus under root b square minus 4ac divided by 2a. Now see, derivatives are same, so x is equivalent to minus b plus minus under root of b square minus 4ac divided by 2a. This method, this is known as the quadratic formula, and this formula was given by Sridhar Acharya, an Indian mathematician who developed this formula, and the procedure was this adopted by this mathematician, and finally we get the formula x is equivalent minus b plus minus under root of b square minus 4ac divided by 2a. So these are we can write also here x is equivalent to minus b plus under root of b square minus 4ac divided by 2a. This is one root. And minus b minus under root of b square minus 4ac divided by 2a, this is another root. So these are the two roots of a quadratic equation simply. And what is this b square minus 4ac? B square minus 4ac, this term, this is called a discriminant. And this b square minus 4ac, if this b square minus 4ac, if this b square, and this usually we represent this by d, if this b square minus 4ac or d is greater than 0, then the quadratic equation has real and unequal roots. Second is, if this d means b square minus 4ac is equal to 0. If it is equal to 0, then the quadratic equation has real and equal roots. And if d is less than 0, only three situations can arise here. Either d can be greater than 0. If it is so, then the equation has real and unequal roots. And if d is equal to 0, then equation has real and equal roots. And if d is less than 0, that is something minus, in minus 4, suppose minus 5 or minus 19, so on, then equation has no real roots. No real roots. So roots are not possible for this if d is less than 0. D means b square minus 4ac. So there are only now two situations when an equation has real roots. First is d is greater than 0. It is a plus sign, obviously. Then the equation has real and unequal roots. If d is equal to 0, then real and equal roots, same roots. But if d is less than 0, then there are no real roots. There are no real roots. So this is how it goes. I will explain it further. You are taking this general quadratic equation ax square plus bx plus c is equal to 0. And from here you are developing this quadratic formula and you are adopting the what? The completing square method. Completing square method, you know it, that you are shifting this constant term towards, this is the first step, towards right hand side. Then you are dividing each term by the quotient of x square. Here we know it is a. So ax square divided by a plus bx divided by a is equal to minus c divided by a. And we are left with x square plus b by ax is equal to minus c by a. Now, adding both sides 1 by 2 into quotient of x, you see here, the quotient of x is minus b by a, sorry, b by a whole square, that is b by 2a whole square. This is the term that you are adding this to the left hand side as well as to the right hand side, and we are left with x plus b by ax plus b by 2a whole square is equal to minus c by plus b by 2a whole square. So both sides we are adding this. Now the square got completed here, so this will become a plus b whole square. For a we are having here x, and for b obviously b by 2a whole square is equivalent. Now solving this further, minus c by a plus b square means b square, 2a square means 4a square, and x plus b by 2a whole square is equal to minus 4ac square plus ab square divided by 4a cube. Now when you shift the square, obviously we will get a root for this right hand side, and solving further we will get x is equal to minus b plus minus under root of b square minus 4ac divided by 2a. This is the famous quadratic formula, and this was given by Sridhar Acharya. Now, applying this quadratic formula, you can find the roots of a quadratic equation. It is so simple now. So, two methods we have already discussed. Now, the third and important method, that is quadratic formula method, and this is so simple. Now this is x square plus 6x plus 8 is equal to 0. Now here we see a is equal to 1. What is b? B is 6. And what is c? It is 8. First of all, we shall see whether roots are possible or not. For that, you know that b square minus 4ac, this is d, discriminant. This should be greater or equal to 0. There are only two situations when a quadratic equation has real roots. That this must be greater than, either d must be greater than 0 or equal to 0. If it is greater than 0, obviously there are real and unequal roots. And if d is equal to 0, then real and equal roots. So let us check whether this b square minus 4ac, this is d is equal to b square minus 4ac. So this is d is equal to b square. What is that? This is 6 whole square minus 4 into a is 1 into c is this 8. So this is 36 minus 32. Obviously 4 greater than 0. So the equations are real and unequal roots. When roots are possible, now you can apply this quadratic formula. What is quadratic formula? Here we go. This is x is equal to minus b plus minus under root of b square minus 4ac divided by 2a. So x is equal to minus b. What is here b? It is minus 6. Minus, this is minus a formula. So here it is 6, that is minus 6 plus minus under root of b square minus 4ac. We have already calculated that is equivalent to 4 divided by 2a. 2 into a, what is a here? It is 1. So this is very simple. So x is equivalent minus 6 plus minus, here we see 4 is the perfect square, that is 2 square divided by 2 square and root will go. And we are left with x is equal to minus 6 plus minus 2 divided by 2. First of all, you will give plus and then minus, so x is equal, we shall write here, x is equal to minus 6 plus 2 divided by 2 and minus 6 minus 2 divided by 2. Obviously, x is equal to minus 4 divided by 2. Minus 6 plus 2 is minus 4. And minus 8 divided by 2. 2 2s are 4, 2 4s are 8. So, x is equal to minus 2, minus 4. These are the two roots of this quadratic equation. It's very simple by applying this quadratic formula. So, this was the third method. All these questions, you will try these questions at your places. The second question is 2x square plus 5, 2x square plus 5x plus 2 is equal to 0. Here we go. It is a is equal to 2. What is b? It is 5. What is c? Is 2. Let's find what is d. D is equal to b square minus 4ac. So this is 5 square. What is b here? It is 5 minus 4 into a is 2 and c is also 2. 5 5s are 25 minus 4 2s are 8 2s are 16. So obviously 9 greater than 0. 25 minus 16 is 9. That is greater than 0. Obviously this equation has the real and unequal roots. So we shall apply the quadratic formula here. Therefore x is equal to minus b plus minus under root of b square minus 4ac divided by 2a. So x is equal to minus b. What is that? It is minus 5 plus minus under root of this b square minus 4ac we have already calculated. This is 9 divided by 2 into a. What is a here? It is 2. So x is equal to minus 5 plus minus, since this 9 is perfect square, 3 square divided by 4 square and root will go. So x is equal to minus 5 plus minus 3 by 4, that is minus 5 plus 3 by 4, then minus 5 minus 3 by 4. So this is minus 2 by 4 and minus 8 divided by 4. 2 1s are 2, 2s are 4, 1s are 4, 2s are. So x is equal to minus 1 by 2 and minus 2. These are the two zeros of the quadratic equation. And rest of the questions of the exercise you will attempt all these by applying this quadratic formula. I think this is very simple now at your places, inshallah. Tomorrow we shall discuss further questions of the exercise word problem. Till then, Allah Hafiz.